Hello everyone. In this video lecture, we're going to talk about functions, right? So functions are basically the actions that you perform on your smart contract. They either get information or they're setting information in response to an incoming transaction. So we have two types of function calls in Solidity. Functions can be called in two ways, right? The one is internal and the another is external. So what are the internal calls? An internal call happens within the same contract or between contracts that inherit from each other, right? So these calls are not going to create EVM message calls. They'll be handled directly within the Ethereum virtual machine. Internal functions and state variables can only be accessed from inside the contract because outside of the contract, nobody knows that they exist, right? And they can also be called from the derived contracts. Think of this like a private helper function in your program. It helps the contract work internally, but no one outside the contract knows about their existence. Then let's come for external calls. External calls, on the other hand, do create up a new EVM call. External functions form the interface of your contract. This is how other contracts, external users are going to interact with your contract. Here's the important part. You can't call an external function directly using your, using f this because it is not going to work. But how can you call it? You can call it by this dot f, right? Which explicitly is going to tell your Solidity that, hey, you're going to make up an external call. So if your function is meant to be accessed by the other contracts or transactions from outside the blockchain, it should be external. Now we have other two categories in which we divide our functions, that are public and private functions. So what are public functions? What are private functions? Let's give it a look. Public function can be called both internally from within the same contract and externally from other contracts or transactions. So these are like open to world. Everybody knows about their existence and are automatically added to your contract's ABI. What is the ABI for your contract? The ABI for your contract stands for Application Binary Interface. You don't need to know this much, just, a common understanding. Then coming to your private functions, on the other hand, are only visible within the contracts they're defined in. Nobody outside know about their existence. It can't be accessed by derived contracts or by anyone outside, right? Unlike your internal functions, they cannot be even called by your derived contracts. Private functions are great for writing helper logic or performing sensitive operations that shouldn't be exposed to anyone outside the contract. Function for updating a state variable. So it's just that you have to change the variable name. You have to change the value for the variable DApp name, DApp name, DApp, remember? If not, please go back to video lectures if you don't remember DApp. What was DApp for? So the parameter value of type string is passed into the function, that is the function name update name. It's declared public, meaning anyone can access it. It's not declared view. We'll see what the view functions are. So it can modify the contract state. And now it's contracted. The app name has been changed to the given value. We don't know what its previous value was, but its new value is value. Okay. Coming to the view functions, if you explicitly mention any function to be a view function, these functions promise you that they're not going to modify the state of your contract's data. Now you will be asking me, how do I know what is modifying the state, what is not modifying the state? I'll let you know in the next upcoming lecture. There is a slide that is prepared specially for this that tells you when and in which ways are you modifying the state of the contract, right? So common examples are getter functions. You might use this to receive a user's balance, but only to receive it and not to make any amendments on it. Yeah, this is the slide I was talking about. What is considered modifying state? Writing to state variables, emitting events, creating other contracts, using self-destruct, sending ether via calls, calling any function not marked view or pure, using low-level calls, using inline assembly that contains certain opcodes. All this is called modifying state. Constructor functions, we've talked about them in the previous lecture as well. Constructor functions are only executed once when your contract is first deployed. Like constructor in many class-based programming languages, let's say C, JavaScript, these functions often initialize state variables to their specified values. Class-based programming language is not C, but CPP. C is your structure-based programming language. though there's not a lot of difference, but just for your understanding. So like constructor in many class-based programming languages, these functions often initialize state variables to their specified values. Owner is made message.sender. So message.sender, anybody who is initializing their contract, their value is set into owner. Built-in functions. In addition to the variables and functions you define in your contract, there are some special built-in functions that exist. Let's say send function, right? Which allows to send ETH to other accounts. Writing functions. Whenever you're writing the functions, whenever you're creating up the functions, what does your function need? That is what this slide is going to talk about. So your function needs parameter variable and time. Parameter variable and type are only needed if it is going to accept the parameter, right? There are some functions we do not like. Let's say I want to print hello world. That print function is just going to print. It does not need a parameter, right? Because there's no variable that I'm going to use it. So declaration, if it's internal, external, declaration, if it's a pure function, view function, payable function. Remember? And the return type. Makes sense? We've talked about get function, set function here. Function calls with named parameters. Now, if you see this, the set on, if I call spdx my first line, and you see sixth line, you want to call the function set, but you have given explicitly the value to key 3. Why? Because if you see the function declaration function set, key is defined before and then value. So if you don't tell explicitly that value is 2 and key is 3, and you mentioned 2 and 3, it is going to take key as 2 and value as 3 because it takes it in order. But if you want to specify in arbitrary order, you need to specify what you're specifying for what. Like in this case, you need to mention value is 2, key is 3. Else, had you given 2 comma 3 and given your function definition for set, uint key and uint value, key would have been 2 and value could have taken the value of 3. So that is why you have explicitly mentioned that, hey, value is 2 and key is 3. Now let's talk about arrays. Arrays can have a compile time fixed size or they can have a dynamic size. The type of an array of fixed size k and element type t is written as t inside the square braces k, and an array of dynamic size as t and inside the inside your square braces nothing. Indices are zero based and access is in the opposite direction of the declaration. Makes sense? If I talk about bytes and strings as arrays, if you're at your access, if you're declaring it this way, this to this way, access is going to be from this element. Make sense? Variable of type bytes and strings are special arrays. The byte type is similar to bytes 1 this, but it is packed tightly in call data and memory. String, we are going to, talk about all this in detail as and when we're going to write functions on this. So let's just see right now. Array members length. Length member tells me how many elements I have in my array, right? So length of memory arrays is fixed, but dynamic, it can depend on runtime parameters once they're created. Push. If you don't give the value inside the parenthesis for push, it is going to give you 0. It is going to append a 0, right? 0 initialized element, it is going to append at the end of your array. And at the same time, if you give x dot push is b, it is going to append b. So it's like it returns the reference to the element and now you can just put in the element, right? It gives you reference to a location and then you give it the value. X dot pushes b means you got an extra location and then you pushed b into it. Make sense? And if you give push x, that means in that external, in that, in the memory location that you took, you have to put x. Makes sense? And this function is going to return you nothing. And then pop function, it's just going to remove an element from the end of the array. This also implicitly calls delete on the removed element. The function returns nothing. Structs, the last slide I'm going to take up in this video lecture. Structs are custom defined types that can group several variables. So if you see struct voter, it has so much things. Unit weight 1, weight 2, weight 3, bool voted addresses, strings, uint for vote 1, vote 2, vote 3, vote 4, vote 5, uint for height 1, height 2, height 3. All these, they're combined together in this in the structure of struct voter. If you have any doubts, any things you want me to make re-clarifying videos on, please help with the doubts in the comment section. Please help with the doubts in your G forms attached, and I'll make sure to address those. Right? With this, if you could extract anything out of the video, just go in, like the video, and subscribe to the channel because I'm getting more such videos in. The playlist is still growing. Bye bye.